If you want to multiply a binary number by 2, 4, 8, 16, you can do so by simply shifting the number to the left to make it bigger. Don't worry about multiplying by 5 or 7 or anything like that. You will not be asked to do that in your exam. Okay, so how do we do this? Well, let me show you how it works. Let's take the number 1, okay, because that's a really easy example to follow. You notice I've padded the rest out with zeros. So if I want to times 1 by 2, okay, so 1 to 2 is 2. So what I've done there, if I write the binary number in there, this, to times by 2, it is shifted left 1 whole place. Okay, so if I want to take the number 1 and times by 4, so 1 times by 4 is 4. So how do I get this to be a number 4? 1, 2. It would require 2 shifts to make that a number 4. Okay. So this is our number here. And what we have done to make this number 4, we've gone 1 shift, 2 shift. Is it going to let me do that? I've gone off the edge of the screen. It's not going to let me do that. But you can see here, this is 4. This is now the number 4. So that took us 2 shifts. How to get this to be times by 8? Let's have a look. So to get this to be times by 8, it would need to move 1, 2, 3 to give us the number 8. So 1 times by 8 is 8. 3. Then 32. Take our number here. How to get this 1 to be 32? Let's get rid of that one in case it's going to be awkward here. It would need to move 1, 2, 3, 4, 5 to get to 32. Okay. Obviously I've missed off 16, but you can see where 16 would fall into that. And then we just fill that back up with the zeros. Like that. Now this doesn't just apply to the number 1, but if you go back to the number 1, if you forget how many, or you can't work out how many shifts it will take, the number 1 is a good starting point. Okay, let's try it with a more, with a larger number. Let's do it with this number here. Okay, so I happen to know that that is the number 15. Okay, but binary 2 decimal 1111. What have I done wrong? An extra bracket. 15. Okay, so I know that's the number 15. What is 15 times by 2? 15 times by 2. Of course, it's 30. So I said 1 shift should give us that answer. So let's go with our original number here. 1 shift. 1 shift to the left to make it bigger. Worked with number 1. Let's see what it does with this number here. Binary check. Let's just check this. So equals binary to decimal 11110. 30. This is the number 30. So it worked. Shifting this number or any number to the left, 1 will give you double. It will times by 2. Right, so I said if you shift it by 2, that is the same as times by 4. All right, so let's have a look. Let's take our number down and times by 4. So for 1 to times by 4, we had to go 1, 2 to make it 4, didn't we? Okay, so that was 2 jumps, 2 shifts. 1, 2 shifts, add 2 zeros. I'm sure most of you can work out what that is, But let's do our binary to decimal. And we are saying, oh, there's another bracket. We are saying 1, 1, 1, 1, 2 zeros this time. 60. 15 times by 4 is 60. All right, so let's try it times by 8. Oops. So times by 8, I said 3 shifts. So 1 to get to 8 was 1, 2, 3 shifts. Okay, so 1, 2, 3 shifts. Fill with zeros. I should also be putting zeros up here, and I'll explain why in a second. So we've got 4 1s and 3 zeros. So 15 times by 8, 120. And let's times it by 32. So I said that was going to need 5 shifts. 1, 2, 3, 4, 5. Okay, and we've got a problem here, haven't we? Because we've gone off the edge. Now, when you go off the edge, it's an overflow error. The exam, I've never seen it give a shift to the left that actually gives you an overflow error. I have seen it in addition. I haven't seen it in binary shifts. It might. If it does, and it asks you to write it out in 8 bits, 1, 2, 3, 4, 5, 6, 7, 8. That's your answer. If it asks you in 8 bits, that's your answer, even though it is the wrong answer. And what's happened is you've got an overflow error. The number is too big to fit in the register or in the memory location that it's been allocated. When you are writing your answer down in an exam, to show you're working, just write down how many shifts you've taken. So write your answer down and just, there's 1 mark. And if you say, I did 2 shifts, 2 times by 4, there's your other mark. If you get an overflow error, you'll get a mark for that if it asks you. And if you do not write your answer in the specific number of bits, so if it asks you for 8 bits, no matter which one it is, if it asks you for 8 bits and you do not write it out in 8 bits, you probably ain't going to get any marks. You have to read the question and write it out in the number of binary digits that it asks for. Dividing by 2, 4, 8, 16 works exactly the same way, except you shift the other way to make the number smaller, like this. So I've got the number 32 here. If I wanted to divide by 2, okay, last time multiplying by 2 was 1 shift. So dividing by 2 is 1 shift. We just go the other way. So what I'm saying to you is this 1 here gets shifted to the right this time to divide by 2. Okay. Let's fill those up. So 32 divided by 16, half of 32, is 16. Yes. So if we divide by 4, last time it was, let's just track this even though we know what they are. Last time, if we multiplied, it was 2 shifts. So I'm saying it is 2 shifts to divide by 4. You just go the other way to make it smaller. 1, 2 shifts. Okay. So is 16 divided by 4 8? Okay, so dividing by 8, so to multiply by 8, it was 1, 2, 3 shifts. So I'm going to say it's 3 shifts, it's just that way. So that's where the number is. It's our original number. 1, 2, 3 shifts. So we are saying 32 divided by 8 is 4. 32 divided by 32. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Five shifts. Okay, so there is a problem with this. Generally in exams, I've seen them being quite kind and they make sure they do what I did and has had sufficient number of zeros. So when you went that way, it didn't cause a fraction. Okay, we don't need to worry about fractions, but let me show you what happens just so you're aware, just in case it does crop up. Let me do that number there. Okay, so denary. Tell you what, we won't bother with the actual values. We just you can work that out. All we're bothered about is the number of shifts and what happens when we get, if it shifts past this point here. So this number here, okay, we're going to divide by 2. We know that if we divide it that way, right, 1, that halves it. Now you notice that this is dropped off the edge. It's a 0, so it doesn't actually make any difference. We just delete. If we divide by 4, likewise, and as I said, if you want to check my logic and work out these numbers, that's fine. Divide by 4 was 2 shifts, 1, 2, and then these zeros we just get rid, and any space that we created we just pad with zeros. It doesn't affect the value. Okay. Divided by 8, 3 shifts. 1, 2, 3. Okay, we've got a problem here. This has gone this side, so we know that. Let's do our denary check. So if we say this equals binary to decimal, and then if we say we expect this to be 60 divided by 8. Okay, so we expect that to be 7.5. We have a problem because it's given us a fraction. We know it's given us a fraction because it's just dropped off the right hand side here. BBC Bite Size call it a decimal point. It's not a decimal point. We're not dealing with decimal. It's a binary point. There's a binary point here. So anything that butchers past this 1 goes into a fraction. All we do at GCSE level is just delete it and we just take the integer value. Okay, so that's obviously 4, 5, 6, 7. So the integer value will be 7. So it gives us an inaccurate answer because we just lose the fraction. But that's just the way it is. That's all you need to worry about. So if you are shifting and the exam board decide to get a bit cruel, so 5 shifts. Okay, so I'll come back. 1, 2, 3, 4, 5. These all go. Which gives us the number 1. And it should be 60 divided by 32, 1.875. So the fraction we just truncate and we just take the integer value. Just do it like that. Very much doubt they'll ask you, but if they do, you understand now. You understand what's going on. Yeah, in a bit.